Okay. So we have completed this graph in the previous class, right? Where was this? We're done with this. Which paper we were doing in the previous class? Yeah, here we go. Okay. So every one of you have made this graph. I told all of you to, right? Okay, I have to check my these values, whether they are correct or not. So it was 0.04 afterwards. Amount of iron 0.493. There we have a 0.493, and on the y-axis amount of chlorine atoms in mole 0.145. Okay, so 0.493 like this, and 0.145. Okay, so it would be over here. I will draw this line again, and at 0.039 we have 0.105, so 0.039, the value is 0.145. Okay. Would be over here. Okay, now that's fine. So if you see, this is the line of respect. Okay. Now there are two points which are little deviated, and here what they are saying in the next part. Circle the point on the graph you consider to be most anomalous. Suggest one reason why this anomaly may have occurred during this experimental procedure. So, if you see the most anomalous point is this one. So, I will circle this point because it is further away from the the line, and now we have to figure out the anomaly why this anomaly actually happened. Yes. Can anybody suggest any reason for this?
The mass was measured wrong.
Sorry, Ahmed, can you repeat?
The mass was measured wrong. The actual value is more than the recorded value.
Okay. Anyone else? So, what masses we have calculated, if you recall? See the diagram over here. We are hitting the iron. We have calculated the mass over here, right? And we are calculating the mass of iron chloride over here, right? And we are introducing dry iron chloride over here. And see, this iron chloride is being the solid that is collected over here. So, and there is a possibility over here that all of the iron chloride formed is not measured. Some of the iron chloride might escape because this iron chloride is actually not forming here. This iron chloride is actually forming here, and it is traveling over from here and getting deposited over here, right? So there is a possibility that some particles of iron chloride might pass out with the chlorine gas. Is this understandable? Yes. See, if you see on the graph, what we are observing that this point must be over here, and instead it is over here. So there is no change in the mass of the iron, but if it is actually over here, then there must be a more mass of iron chloride, right? So it means there is a variation or there is an error in measuring or getting the mass of iron chloride. And if you see the experiment over here again, as the chlorine gas passes over iron and that iron is heated, so the iron chloride is actually formed over here. Is this point is clear?
Yes, sir.
Okay. So when this iron chloride is forming over here, it is also traveling with the chlorine gas over here, and the one which is deposited over here, we would be able to take the mass, and as the chlorine gas is leaving from here, so there is a possibility that particles of iron chloride also can leave from this place. Is this understandable? Yes. If anyone have any doubt, kindly ask. Okay. So we can write over here that some of the iron chloride might escape might escape with chlorine. Is this part clear? Now, next part. Use the graph to determine the gradient of the line of respect. State the coordinates of both points you used in your calculation. These might be in your line of respect. Give your answer to three significant figures. Okay, do it on your own. And the one who have a, you know, who draw this line perfect can tell me its coordinate. Mine is not correct. Yes, who is going to be telling the coordinates? Yes, kindly tell me the coordinates quickly. Yes, can anybody tell me Hanna, Ahmad?
Sir, we can use the first coordinate as the last value of the table and the second as 0, 0 because the gradient passes through origin.
Okay.
Sir, shouldn't the points be like far apart? Like more than half of the line?
I can't hear you Hanna properly. Can you repeat?
Shouldn't be both the points far apart, like more than half of the line? The distance between the points.
Yeah, we can take the parts far apart. It doesn't matter. You have to take
Like
the two coordinates from the lines. That's it. So, but just tell me the values.
0.0102
0.0102.
and 0.0301.
You're telling me coordinate
X
one,
and Y. Yes.
right? And the y is
0.0301.
2.0301. Okay. Now coordinate 2.
So I chose the last coordinate for coordinate 2, so it's 0.0699
0.0699.
and 0.205.
0.205.
20.
Okay. So just find the coordinate. It would be 0.205 minus 0.0301 divided by 0.0699 minus 0.010.
Gradient is 2.930.
2.930.
930.
Okay. So the gradient is 2.930. Yes, everybody else also solved it. Yes, Ahmed, what gradient you are getting?
I'm redrawing my gradient.
Okay, what about you, Mariam? Alishka, anyone else who have calculated the gradient? Mahi, Mubashir, and Musa. Yes, Mubashir and Musa, have you drawn and calculated the gradient? Yes, Rafael, Soleva, Ania,
Done, sir.
what value you are getting?
Same 2.930.
Okay,
Sir, 2.86.
2 point.
2.86.
Okay, that's fine. It seems that you both did correct because there is some possibility due to might be the graph that you are getting a little difference in your values, but it's fine if you are getting 2.86. Okay, next part. The formula of the chloride of iron produced in this experiment is the FeCl3. Yet how the results student 4 obtained could be used to define this formula. Yes. Yes, how can we determine the formula that it is FeCl3? How the results student 4 obtain? Okay.
सर मोल रेशियो फाइंड करेंगे.
Yeah, very good, Mariam. And from where we take the we have the moles of at different points, right? So we can take the mole ratio. So, for example, if you take the first two values, if you look at the first data, or you can look at this data, you are getting that it could be 1:3. So, for example, if I use experiment 2 from 2, what I am getting for iron, it's 0.017, and for chlorine, it's 0.0580, right? So, from experiment 2, take the ratio of their moles. The mole that for the iron was,
Sir,
yes,
sir, don't we have to use only one value like for student 4?
so it was the results student 4. We're talking about this one. Okay, yeah, these are the students, sorry. So take the values from the 4. It is 0.0349. Okay, that's good. So 0.0349 is to, what is the mass of chlorine? Moles of chlorine, 0.103, right? And here we are not going to get the actual value, I suppose. So 0.0 or might be 349 over 349. So 1 is to, just what value you are getting over here?
2.95.
2.95. So it is getting closer to, we can round off it to 3, okay? Is this part is clear?
Yes, sir.
Okay, now student 3 weighs the conical glass using a balance accurate to 2 decimal places and record its mass. 2 decimal places means the lowest value that can be weighed is 0.01 grams because the unit is gram. After the chloride of iron is produced, the mass increased by 4.03. Okay. Calculate the percentage error in measuring the mass of this chloride of iron. Yes. So it's the least count, and from the least count divided by 2, I am going to get the error, that the chance of the error will be plus minus 0.005. But if you recall the mass of chloride of iron, how could we measure this mass? See here that we put in the 2 additional measurements. So we need the mass of the empty side on conical glass, right? And then when it is formed over here, then we mass it again. So we are taking the mass twice and then subtracting the 2 masses to get the mass of the chloride of iron, right? So it means we are choosing twice. So the error would be 0.005 in the first reading only. So there must be, we have taken the 2 readings. So it must be times 2 divided by the total mass, that is 4.03 multiplied by 100. Now calculate it and find the percentage error.
0.248.
Okay, 0.248%. That is the percentage error. Okay, now student 8 follows the same procedure as the student 3. State whether the result from the student 8 will have more or less percentage error than those from student 3. Explain your answer. Okay. There is an increase in mass of 4.03 by student 3. So if you see, that is the student 3, right? Here the mass is 0.0741. Sorry. Here the mass is 4.03, and for student 8 the mass is 9.80. So yes, what would happen? Now,
Error.
yes,
Yes, error.
less error, very good, because the error remains same, and you want, you can show it like this. Whatever the mass is provided for student 8, it's 9.80, sorry, and multiply by 1000, or sorry, multiply by 100, and we can say that as larger mass, see over here, is used. So the percentage error decreased. Is this understandable to everyone? Yes?
Yes, sir.
Okay. Now F part. Another student suggested that the chloride of iron could be prepared by the reaction of iron with the hydrochloric acid. A sample of a chloride of iron prepared in this way contains 44% iron biomass. Okay. Show that a formula of this chloride of iron is FeCl2. So what we have to do? We have to find the formula. So mass of chlorine would be 100 minus 44, which means 56. So now iron is to chlorine. The mass of iron is 44 divided by its MR, which is 55.8, and the mass of chlorine is 56 divided by 35.5. Now, can anyone tell me the answers?
0.7885
0.7885 and
and 1.5775.
1.577. So this one is the lowest, smallest. So divide with this. So it could give me 1, and I think it could give me 2. So 1 is to 2, so it is FeCl2. Yes. Is this clear to everyone? Now the next part. Explain using the electrode potential values in the table why the method in A and F do not produce the same chlorides of iron. Yes. Yes, who can answer this? We are already going on a discussion on electrode. We had it yesterday as well. Yes, who will answer? Okay. See, in method A, we are getting FeCl3, right? And that FeCl3 is forming from iron metal. That is our method A. And in method F, we are getting FeCl2. That is our method F, right? So if you look at these two, iron have a zero oxidation number over here. Here iron is oxidized to positive 3, and here iron is oxidized to positive 2 in method F, right? This part is understandable to everyone?
Yes, sir.
Yeah. Now see, if you have to form Fe2 positive from iron metal, the potential of this half reaction is minus 0.44 volt, right? And if you look at these half equations, these are suggesting that in the first step, and then this would be the second step. And for that, where iron 2 positive is converting into iron 3 positive, its potential is positive 0.77 volt, right? And on the other side, we are reacting it with a hydrochloric acid where we have a hydrogen ions. So it means during this reaction, if you write the equation over here, iron wire and hydrochloric acid. Let me write over here iron wire and hydrochloric acid, and they told you that iron chloride is formed along with a hydrogen. So here hydrogen is +1, here hydrogen is 0, here iron is +1, here 0, and here iron is +2. So see, hydrogen is reduced and iron is oxidized. So the one which oxidized have a smaller value and the one which reduced have a higher value. Right? So if you compare these two, hydrogen have a reduction, its value is 0.00, and when iron 2 positive have to oxidize it to Fe3 positive, its value goes 0.77, which is higher than the hydrogen one. So it means hydrogen cannot oxidize iron 2 positive to iron 3 positive. Iron 2 positive to iron 3 positive. Is it clear?
Yes, sir.
Yes, if anybody have any doubt or confusion to ask, so we can say it's easier. See, how can you further write it? As we decided, it would go undergo oxidation and it would undergo reduction. So you would solve it with the E reduction minus E oxidation. So the reduction will have a value of 0.00 and the oxidation have a value of 0.77. So what I am going to get, I am getting negative 0.75 volt. So after this, I can say as its E naught cell is negative, the reaction between Fe2 positive and hydrogen ion is not feasible. Yes, is this clear to anyone? Yes, if anybody have any doubt, kindly ask.
There isn't the value of hydrogen less, then why are we putting it in reduction?
Because according to the condition, we are assuming that if we assume if hydrogen will further reduce, then it can able to oxidize iron into iron 3 positive, iron 2 positive into iron 3 positive, right?
Right,
So we just when we solved it, the value that we got over here have a negative, right?
right,
So for as the value is negative, that's why we concluded that E naught cell is negative, so the reaction is not feasible. So it means that the reaction, if I put the value of hydrogen over here, it indicates me that the reaction could not take place because I'm getting the negative value.
right, sir.
If you still have any confusion to ask. Yes, is it clear to everyone? Okay, we are done with question number 2, and I think we didn't start at question number 1. So tomorrow we have a class at around 5:15, and then we will start question number 1, and I have shared the next copy. Afterwards, if we've got a time, so we will continue the next paper 5 tomorrow. Okay. So see you everyone tomorrow at 5:15. Okay then. Take care everyone. Allah Hafiz.